Hello and welcome back to another AP3 video, and in today's video we'll be going over SAT math questions, more specifically circle questions that pop up on the SAT. The questions that we're going to be doing today are either medium or hard questions. So half of it's going to be medium and half of it's going to be hard questions. In the X and Y plane, points P, Q, R, and T lie on the circle with center O. So O is the center. The degree measure of POQ and ROT are 30 degrees. What is the radian of the angle QRO? So we're given a lot of information. So I'm given that O is the center, and I'm given that POQ. So let me rewrite that. POQ and ROT equal 30 degrees. So if I look at the circle, let me redraw it really quickly. So the center is O, and they're giving me R. O is the center, and then T is over here. So over here we have the angle measure of 30 degrees. And then if I draw POQ, so P is over here and then Q is on top. So we have another angle measure. I get 30 as well. And then we're looking for the radiant measure of QOR. So what's like here basically. So what I like to do is think about it like this, right? In a full circle, we have the angle measure of 360. In a semicircle, we have the angle measure of 180. So this line that goes through T is 180, or the semicircle. So what we want to do is add 60. We add 30 plus 30, and we get 60. And we do 180 minus 60 to get the angle measure of QOR, because QOR, if we have the angle measure, that will give us half of the circle, and half of the circle in degrees is 180, or a semicircle equals 180 degrees. So if we do 30 plus 30, so 30 degrees plus 30 degrees, that equals 60. That equals 60 degrees. And if I do 180 degrees minus 60 degrees, I get 120 degrees. And 120 degrees is the angle measure of angle QRO. So QOR, sorry. So QOR equals 120 degrees. So what I can do now with 120 degrees is I can convert degrees into radians by multiplying pi divided by 180, because if you want to convert degrees to radians, what I want to do is multiply pi divided by 180. And then when I have radians to degrees, I want to do the opposite. I would multiply 180 degrees and divide it by pi. In this case, we're looking for the radian measure of angle QRO. We're given the degrees, so we want to convert it to radians. So we would do 120 degrees multiplied by pi divided by 180 degrees. And if we write that as a fraction, we get 120 degrees over 180 degrees, and then pi is of 120. So if we multiply, or actually if we divide 120 divided by 180, we're going to get the values of 0.666, many sixes, and then 7. And if we compare that to C, and C is 2 pi over 3, if I do 2 divided by 3, I still get 0.66, many sixes, and then 7. Therefore, 120 pi divided by 80 is equal or equivalent to 2 pi over 3, because it's just simplified. So the answer is C. And you can see that because if I do 2 pi over 3 and I multiply both sides by 60, that equals 120 pi over 180. So therefore, they're both equal, and it's just simplified answer. Therefore, our answer is C. Okay, this is a medium question now. In the X and Y plane, a circle has the radius of 5 and has the center of -8, 6. Which of the following is an equation of the circle? So equation of a circle, it is a formula, or an equation formula, that looks like x minus h squared plus y minus k squared equals r squared. So r is the radius, and x and y are the center values, but the opposite. What do I mean? So as we can see, we just multiply radius squared. So we can plug in 5, and if we do 5 squared, we get 25 for the right portion of the equation. Therefore, C and D are already incorrect. So what we want to do now is figure out what the x and the y values are. The good thing about it is that the rule is that whatever x is or y is in the center, it's just the opposite. So what does that mean exactly? So instead of x being negative 8 in the equation, I write x plus 8, because when we solve for x, I would make x plus 8 0, so x plus 8 equals 0. And if I solve for x, I get x equals negative 8, which is the same thing as the center over here of negative 8. So I do the same thing with 6. So what's the opposite of 6? Negative 6. And when I solve for y on the equation, I get y minus 6 equals 0, and I get y equals 6, which again goes with the center of the circle. Therefore, our answer has to be where 8 is positive, or it equals x plus 8 squared, and then we get plus y minus 6 squared, and therefore our answer is B. And then A is incorrect because we need to flip it in the equation. So we flip the negative or the positive value of the center of the circle. So if I had negative 8, it would be positive 8 or plus 8 with the x. And if I have 6, it would be negative 6 or minus 6 with the y. Okay, now we're going to go over a SAT question I did in a previous video, but I'm bringing it back because these type of questions are really important because it relates to circles, and these questions pop up a lot in the actual SAT relating to degrees and radians. The measure of angle R is 2 pi divided by 3 radians. The angle measure of T is 5 pi divided by 12 radians greater than the measure of angle R. What is the measure of angle T in degrees? So I'm giving 2 bits of information, that the angle measure of R is 2 pi divided by 3 radians, and the angle measure of T is 5 pi divided by 12 radians greater than the measure of angle R, and we're looking for the measurement of angle, oops, it's on highlighter. We're looking for the measurement of angle T in degrees. So let me write what's given. So angle R is 2 pi divided by 3, and then angle T is 5 pi divided by 12 greater than angle R. So I'm just going to greater than R. So what does that mean is that we need to add 5 pi divided by 12 with the angle measure in radians of R to find the angle measure of T, because angle measure of T it's given that it's 5 pi divided by 12 greater, so we add it with angle of R to get the angle measure of T. So in reality, we would do, I'm gonna draw this like a little note point. You're gonna get 5 pi divided by 12 plus 2 pi divided by 3 to get the angle measure of T. So I'm just gonna write AT. So let's convert everything into degrees so we can figure out what is the solution. So remember, like we just went over, to convert degrees into radians, I would want to do pi divided by 180 degrees, and then from radians into degrees, I do the opposite. I do 180 degrees divided by pi. In this case, we want to convert from radians into degrees. So what I want to do is multiply everything by 180 divided by pi to convert everything into degrees. So for angle R, or 2 pi divided by 3, I would multiply that with 180 degrees angle measure divided by pi to get the angle measure of angle R. So the pi's cancel out, and then I get 360 divided by 3, which just equals 120 degrees. So the angle measurement of R is 120 degrees. So now that we know that 2 pi divided by 3 is 120, I can substitute that to find angle T. So plus 120 degrees. So now what I want to do now is figure out the angle measure of 5 pi divided by 12 and then add it to the angle measure of R to get T. So I would do 5 pi divided by 120 divided by 12. That's my mistake. So 5 pi divided by 12 and convert that into degrees the same way, multiplying by 180 degrees divided by pi. The pi's cancel out, and then I get 900 angle measure divided by 12. So if I plug that into a calculator, because I cannot do that mentally, honestly, if I do 900 divided by 12, I get 75. So it equals, we add 120 degrees with 75 angle degrees. So I do 75 plus 120, and then the measurement of angle T in degrees is 195 195 degrees, 195 measurement in degrees. So the answer is C. Okay, now let's do the hard questions now. The graph of x squared plus x plus y squared plus y equals 199 divided by 2. And the x and y plane is a circle. What is the length of the circle's radius? So what we want to do is convert this huge equation to the actual equation of a circle, which is again x minus h squared plus y minus k squared equals radius squared. So r is radius. So what we want to do is rewrite the equation that we have. So x squared plus x plus y squared plus y, and that equals 199 divided by 2. And what we want to do, and this is really important, is to complete the square. So how do we do that? Well, there's a rule that the formula is b divided by 2 squared in order to complete the square. And how can we write that? So what we want to do is expand the equation that we have right now. So what we would want to do is make it into like a quadratic equation so we can find our a and b and c value. So we would do x squared plus x plus blank, so blank is c, and then plus y squared plus y plus blank, this would be c for y, which would equal 199 divided by 2. So if we look at a regular quadratic equation, that is ax squared plus bx plus c. In this case, for both x squared and y squared, a equals 1, and then b for both x and y, that equals 1, and then c equals, we don't know yet because that's what we're looking for. So now that we know that b equals 1 for both, we plug it into the rule. So I would get 1 divided by 2 squared, which would equal 1/4, and we plug that in for the c value. So now that we know that c equals 1/4, so c equals 1/4, and I plugged in for the x and y value because we both have the same a, b, and c value. So notice how I added 1/4 on the right side, the left side. I want to add 1/4 also on the right side, so I'll get 199 divided by 2 plus 2 1/4, or equals 2/4, or plus 1/2, because that's equivalent, because 2/4 equals 1/2 if you simplify it. So you would get 199 plus 1/2. So you can rewrite the equation as x squared plus x plus 1/4 plus y squared plus y plus 1/4, which would equal 199 plus 1/2, which would equal 200 divided by 2, or simply just 100. 100. And so now what I want to do now is that I want to complete the perfect squares. So the perfect square for x squared plus 1/4 and y squared plus y plus 1/4 is, for x would be x x plus 1/2 squared, and the same thing for y, plus y plus 1/2 squared, which would equal 100. And notice how it's in the circle of the equation formula. I remember we're looking for the length of the circle's radius, and the radius we can find it by looking at the right side of the equation, r squared. So what we want to do is do 100 equals radius squared. I want to look for the square root of both. The square root of r squared cancels out, so I'm left with r by itself, and the square root of 100 is just 10. Therefore my radius is 10 in this equation. We already had it over here, but I want to show you guys how to simplify the actual full equation into the circle of the equation, so you guys can understand how to do it. And if you multiply x plus 1/2 squared, or y, if you expand it, I'll get x plus 1/2 multiplied by x plus 1/2. The x multiplies to get x squared, the 1/2 multiplied to get 1/4, and if I do x multiplied by 1/2 and then 1/2 multiplied by x, so here and here, I'm left off with x by itself. And it's the same thing for y, and therefore that's why I'm able to rewrite it in a complete square, or like in a condensed format, being x plus 1/2 squared. So I forgot we had one more medium question. I completely skipped it, but we're going to go over it right now. An angle measure has a measure of 16 pi divided by 15 radians. What is the measure of the angle in degrees? So all we have to do in this type of question is honestly just convert radians into degrees. And you can solve this in less than a minute. So we would do 16 pi divided by 15. And now that we know our radians and degrees rules, because we're converting it into degrees, what I would want to do is multiply 180 degrees divided by pi's. The pi's cancel out, and I'm left with 16 times 180. I'm gonna plug this into a calculator because it's gonna give me a really big number. 16 times 180, and that equals 2,880, which equals 2,880 angle degrees. And then we divide that by 15, and then we should get our answer. So 2,880 divided by 15, I'm going to get the angle measure that equals 192, and that is our answer. You see, less than a minute, and it's already solved. Okay, let's go over a hard question that we did previously on a different SAT video. Remember, the more we practice hard questions, the better you're going to understand it during test day, and that is the most important part. A circle on the XY plane has its center at -4, -6, and line K is tangent to the circle at point -7, -7. What is the slope of K? So I'm given that the center of the circle is -4, -6. So let me draw the circle as fast as I can. So we have a circle. And we have the point in the middle of -4 and -6. What I'm also given is that there's a tangent line. Line K is tangent. Let me do this in highlighter. Line K is tangent to the circle at point -7, -7. So down over here, I have the point -7 and -7. And we have tangent line, which how tangent line works in a circle is that it crosses the circle at exactly one point, and it's just a straight line passing it. So it kind of looks like that. So what's good about the tangent? Oops. So what's good about, and this is line K. But notice how if I draw the radius, which looks like this. So this is our radius. Notice how the radius and line K are perpendicular, and I drew the radius because any point that goes from a point of the circle to the center, that's always the radius. So I have the radius, I have the line K, and as we can see, they kind of make like a perpendicular line. So when lines are perpendicular, that means that the slopes are reciprocal. Therefore, line K slope is reciprocal to the radius line. So you might be asking, what does reciprocal mean exactly? Well, if I have a slope on one equation of -1/5, the reciprocal slope would be the opposite sign, so be positive, and the fraction flips as well, so +5. And then if I do another example, slope of -6 divided by 7, the reciprocal of the slope is 7/6. And if you switch the slopes reciprocally, you're going to get perpendicular lines. So line K and the radius line needs to be reciprocal in order to create the perpendicular lines. So now what we want to do is look for the slope of the radius to find the reciprocal of line K. And as we can see, we're given 2 points. So what we can do is use the slope formula, which is y2 minus y1 over x2 minus x1. Whoops, let me draw the y's a little bit better. To look for slope. Okay, so I'm given -7, -7, and -4, -6. And as we can see, -4 is greater than -7, and -6 is greater than -7. So therefore, -4, -6 are my x2. I'm going to draw it in yellow. These are my x2 and y2 values, while the -7s are my x1 and y1 values. So now I plug that into the equation. So I would do -6 with y1, and then plus y2, which equals 7, and then we divide it by x2, which equals -4, and then I do plus 7 as well. I get -6 plus 7, I get +1. And then -4 plus 7, I get 3. So 1/3 is slope for radius, or r. And then if the slope of the radius is 1, 3, the reciprocal is -3. So line K, therefore, has slope of -3, because -3 and +1 divided by 3 are reciprocal, leading to perpendicular lines. Therefore, my answer to the slope of line K is A. Okay, this question's actually pretty tricky. It took me some time to understand it, so let's take our time. In the x to y plane, the graph of 2x squared minus 6x plus 2y squared plus 2y equals 45 is a circle. What is the radius of the circle? So I'm given this huge equation over here, which is a circle, and we're looking for the radius of the circle. But we can't look for the radius because it's not in the circle of equation format, which is, again, I'm going to keep rewriting it because the way to understand it is by repetition and practice. So circle of equation is x minus h squared plus y minus k squared equal radius squared. So I'm going to rewrite what's given. And let's do pink. So I have 2x squared minus 6x plus 2y squared plus 2y, which equals 45. What I would want to do now is divide everything by 2 in order to get x squared and y squared by itself, so we can look for the complete squared. Because there's a 2 on both x squared and y squared, we can now do complete squared, like we did in one of the previous problems. So what we want to do is divide everything by 2. Divide everything by 2. I would get x squared minus 3x plus y squared plus y, which equals 22.5. And it's going to look a little bit weird because it's going to be in decimal format for now. So now I can do is complete square. So the same thing, we're going to use b over 2 squared in order to look for the complete square. So I have to convert everything into, again, the quadratic equation. So I'm going to do this in green. I'm going to get x squared minus 3x plus blank, which is c, and then plus y squared plus y plus blank, which is c, equals 22.5. Let's do -3 because -3 is being this equation. So if I do -3 over 2 squared, and if I plugged it into a calculator, so if I do -3 divided by 2 squared, so -0.5 squared, so -1.5 squared, I am going to get positive 2.25. So this equals 2.25, and I add that on the c, so 2.25, and I add that on the right side, so 2.25 plus 2, so 22.5, and then plus 2.5, I add it on both sides because whatever I add on the left side, I add on the right side. So that is for x. So let's do y now. If I do y, I realize that my b equals 1. So I would do 1 divided by 2 squared, which equals 1/4. But if we want to make it easier and convert into a decimal, it would equal 0.25. So 1/4 equals 0.25. And I add that on the y value. So c on y equals 0.25. And I add that on the right side. So 0.25. So I'm going to switch it to blue, and I'm going to write everything on top. So I have now x squared minus 3x plus 2.25. And then plus y squared, sorry, and then plus y, and plus 1 divided by 4, or 0.25, which equals, and if I do 22.5 and then plus 2.5 and then plus 0.225, which also equals 22.5 plus 2.5, I'm going to get the value of 25, so which equals 25 squared, or 25 by itself. And we're looking for the radius, and because I already add all the values on the left side to the right side, I can look for the radius now. So like we did last time, we'll do 25 equals r squared, and I find the square root on both sides. Their square roots cancel out on r, and I get r equals square root of 25, and r equals positive or minus 5, but the only answer we have the choice is positive 5. Therefore, our answer is r equals 5. So the answer is A. Okay, let's go over another hard question. In the x and y plane, the graph of the equation above is a circle. Point P is on a circle and has the coordinates of 10, -5. If PQ is the diameter of the circle, what is the coordinate of point Q? So I'm given a circle, obviously. But before I do anything, I want to understand what's given in the equation of a circle, which is written over here. So we don't have to do no complete square because it's already in the circle of the equation. Notice how I have x minus 6 and y plus 5. That gives me the center. Like I said, it's the opposite of 6 and -5, which is our center. So 6 and then -5. They also tell me I have 16. As we remember, after circle of equation on the right side, that equals radius squared. So radius squared equals 16. And if I solve for r, I get r equals plus or minus 4. In this case, is r equals positive 4. So radius equals 4. What I'm given is that the point P is on the circle with the coordinates of 10, -5. So 10, -5 is one of the coordinates. But notice something. Notice the y value of the center, -5. And look at the y value of point P, -5. So what does that mean? It just moved in a line. We're just moving four things on the right side only. So we're not going up and down because the y value stays the same. We're just adding 4 to get 10. So we would have the radius going from the middle to the right side over here, which is the radius. And then I would get the point 10, -5, because I'm just adding 4 with 6. And they tell me if QP is the diameter of the circle, what is the coordinate of Q? The way to find Q is the same as what we did. Instead of adding, we're going to subtract 4 from 6 to get the opposite side of the line of PQ, which is right here. And if then from point from point Q to P, that equals the diameter, and we just gotta look for the radius over here to get the diameter, because the full line is the diameter, but half of it of the center is the radius. So diameter is the full thing, radius is 1/2. So what I have to do is look for the point that would happen on me. We would get the point that would create the diameter. So the y value again stays the same, therefore B and D are incorrect. And what we want to do is subtract 4 to get the value of Q, which would equal 2 and -5, because we're just subtracting 4. And therefore my answer is A, because if I do C, that's just the center. But if I get A, I realize I get point Q, and if I look from point Q to point P, I have the diameter. So the answer is A, because I add 4 to go to the center of 6, -5, and I add 4 to go to 10, -5, and therefore because I move the radius, I move from Q to the middle and middle to P, that means I moved 4 2 times, and that would equal the diameter. Okay, this is the hardest question that we'll be doing today. I drew the circles the best way as I can because there's a lot of notes, or there's a lot of information that we have to write down. So let's go over everything. Point O is the center of the circle above. The measure of OAB is 30 degrees. If the length of OC is 18, what is the length of arc AB? So we're given that the length of OC is 18. So I'm going to draw that in green. 18, and they also gave me that the angle measure of OAB is 30, so equals 30 over here. But notice something, OC is radius because it creates a line that goes from one point to the center of the circle. So OC is radius, therefore a radius, oops, I made a mistake here, it's not 18 degrees, therefore the radius, R, equals 18. So now let's look what we're given. Well, because OA and OB are radii of the circle centered at point O, meaning that we have 2 points that enter the radius, these segments have equal lengths because the radius, no matter what point I draw, whether it's from here, or from here, they're always going to make a radius, and the radius is always from one point to the center. And because from one point of the circle to the center equals the same amount, OA and OB have the same equal lengths. Therefore, OAB is an isosceles triangle where angles OAB and OBA are congruent base angles of the triangle. It's given that OAB is 30 degrees. So we rewrote that. OAB is 30 degrees. And therefore, because it's an isosceles triangle which has two equal lengths and two equal angle corresponding to each other, therefore angle OBA is 30 as well. So it equals 30 here as well. So let me draw that in green, sorry. So we can color code it. So it equals 30 over here. So let's represent the measure of the angle OAB. So we know that a full triangle equals 180. So to look for the angle measure of O in the triangle OAB, we can add both 30s, which equals 60 degrees, and subtract it by 180 to look for the angle measure of O, because in the triangle, the angle measure is always 360. So 180 degrees minus 60 degrees, that equals 120 degrees. Therefore, the angle measure of OAB is 120 degrees. Okay, so now we have that. And if we plug that in and we make that into radians, that would equal, so 120 to radians, like we did in the previous questions, we would do pi divided by 180 degrees, which just equals 2 pi divided by 3 radians. So 120 in radians, which equals 2 pi divided by 3 radians. And that's important because it will help us to look for what we're looking for. So we're looking for the arc length of AB. And there's a formula to find the arc, so which is S equals the radius with the radians of the arc of AB. So what am I given? I'm given that the radius is 18. So I just plug in equals 18 multiplied by the radians of the arc. And we're given that the radians of the arc measure is 2 pi divided by 3 radians. So therefore, I just plug that in for the radians. So 18 multiplied by 2 pi over 3 will give me the length of AB, the arc length of AB. And if I multiply 18 times 2 pi divided by 3, I'm going to get 12 pi, and therefore our answer is B. This is honestly a really hard question, and there's a lot of rules you need to understand with isosceles, with radius, and once you understand that, this question can be really easy, but it will take some time. That is the end of the video. Thank you for watching.